Okay, so for the last part, what I want to do is what we just talked about, but in general. Okay, so that actually, let's do the example of 3 and 1 again. 3 and 1, and I get square root of 3. Okay. So I have a diameter of a circle, which is...
It's 4.
The height is the square root of 3. And when I have that height, I get a right triangle because that triangle is inscribed and its hypotenuse is the diameter. Okay?
Yeah.
What's the radius of this circle?
It's 2.
It's 2. So that's in the middle here. So if I go up, it's 2. And I get a relationship between 2 and the square root of 3, which is what?
2 is bigger than the square root of 3.
Yeah, this picture tells you that 2 is bigger than the square root of 3. Now, we already knew that.
Yeah. Because 2 is the square root of 4.
Because 2 is the square root of 4. But it turns out that I can do this in general now. I can call this length x to here, and this length y. And if I do what you did, call that angle 1 and this angle 2, and this is the height, then that becomes angle 1, that becomes angle 2. So the things opposite angle 2 are x and h. So I get x to h equals the things opposite angle 1, h to y. And I get h squared, cross multiplying, is xy, or h is the square root of xy. Okay? That's the height. What's the radius of this circle now?
It's x plus y over 2.
So I get a relationship from the geometry that tells me x plus y over 2 is greater than or equal to the square root of xy. And the reason I said greater than or equal to, if these things were equal, x and x.
X and y.
Yeah, if x and y were equal,
Yeah.
so they were x and x, the radius would be x, the square root of x squared would be x, so it could be equal, right?
Yeah.
But this is an amazing result. Purely from the geometry, I get this algebraic relationship that the average of the two numbers added together divided by 2, is greater than the square root of their product. Just from the geometry. And I do want to do a second video on this one. I know I said this was the last thing, but I want to show you the algebra now behind this. Okay, if we were just trying to prove this using algebra without any geometric insight, it's a little trickier. Okay?
Yep.
Let's do that.